Hi there. Section 8.4, one more section about testing claims, this time the standard deviation. So whenever we're using a single standard deviation, we're going to be using chi-squared, which is this little formula right here. It's got n minus 1 times s squared divided by sigma squared. So the s right there will be coming from the sample information, and the sigma is going to be coming from the claim. Remember that the chi-squared distribution starts at 0 and then proceeds from there. So there's no negative values. So that means when you look up the critical values, you can't just say, I'm going to look up one and the other one's the same number except negative. They are two separate numbers. And the table for chi-squared is A4, and I like to make the pairs here. So the right critical values are on the right side of the table, the left critical values are on the left side. And degrees of freedom is n minus 1. And then let's start with an example. So in a college class, if a test is worth 100 points, the standard deviation should be 15. Now let's compare college students to first grade students. So for the first graders, test the claim the standard deviation is not equal to 15. And the information that I got was on spelling of words. Out of 100 words, how many they spelled correctly on a test. And then here's the scores, 73, 75, etc. So what we'll need to do is put those into the calculator in, say, list 1, and then find the mean and standard deviation. Although we don't need the mean, we just need the standard deviation S and the sample size 21. So S is the 33.773, and that's 21 students. So the claim is about standard deviation, so that uses sigma. I said it would not equal 15. H1 is going to be the same in this case because it's not equals, and that means it's a two-tailed test. And, oh no, HO should say, sorry about that, HO should say it equals 15. There. Now I don't have to redo the whole video. Okay, so here's the sample information, and then we'll be using 95% level of confidence because in the directions I didn't say what to use for level of confidence, so use 95 as a default. And then draw the little picture. So degrees of freedom would be n minus 1, so that's 20. There would be 95% in the middle, and that leaves 2.5% for the left side and 2.5% for the right side. And then look up the critical values. So using 0.025, so using this one right here, then go down to degrees of freedom is 20, so that's going to be this row right here. So if you follow this column down, that would be right here, 34.17, and then follow this little red line at the top and use 0.975 column, and then this one would be 9.591. So then put those on the little chart. Make sure I got them right. Yes, that looks correct. Excellent. Okay, thank you. Next up, the little formula. So unfortunately, this one is not in the calculator. You do need to calculate it yourself. But thank goodness it's just a little formula. So right here is degrees of freedom. This is the S that's coming from the sample information. And then 15 is the number that comes from the claim. Pop that into a calculator and it says that it's going to be 101.388. And that would land way over to the right. So that means that we did actually prove something. So reject H sub O. It's not equal to 15. The claim said it's not equal to 15. So first you say reject H sub O, and it turns out the claim is true. In fact, the variation for the first graders is much higher than 15. Okay, so as far as this class, we can prove things numerically, but then we can't go on and say why. So this isn't a psychology or an education class, so I can't go on and explain why that's true. All I can say is, yeah, it's not equal to 15. All right, next up. There we go. So this automatic coffee machine, it's supposed to dispense 12 ounces. Standard deviation needs to be below 0.5 of an ounce. So it's tested 43 times. The mean was 11.8, so a little bit low, but not bad. But the standard deviation was 0.72. So, is the machine out of whack? Does it need to be repaired? So, it's supposed to be a standard deviation below 0.5. But is it out of control? Is it above 0.5? If it's above 0.5, then it probably needs to be repaired. This was based on just 43 times. Is that enough evidence to prove that yes, in general, the standard deviation is going to be above 0.5, and yes, it needs to be repaired? Or if you got a lot of money, just replace it, buy a new one. So, write down the sample information. And again, in the directions I forgot to say, which I quite often do at this point in the semester, leave off the confidence level, so that means use 95% confidence level, so the alpha equals 0.05. And then draw the little artwork using degrees of freedom is 42. And since it's right tail, 0.05 is the right side. Hey, get back here. All right, then for the table. So it is 0.05 on the right side, so that's using this column right here, 0.05. And degrees of freedom is 42, but they don't have 42. So I have to use whatever's closest. In this case, that's a 40. And then if you go over to the right, the critical value is 55.758. 55.758. And then also I appreciate if you do this and say, I couldn't find 42, I had to use 40. Then do the little formula. So it's going to be n minus 1. The S is 0.72, and the number from the claim, 0.5. You square both of those standard deviations. It turns out to be an 87.091. And that also lands far to the right, which means that we did actually prove something. So the official way to say that is reject H sub O. And then the claim is true. So that means that this has too much variation. The machine needs to be repaired. Or like I said, if they're rich, just buy a new one. All right, I'll see you over in chapter 9.